Hello students, welcome to Math Fam. So today we'll be taking sine cosine rule from our trigonometry topic here. This is sine and cosine rule that is very useful when you are solving the trigonometry question or application based question from criteria D. Now here what is written here, where do we use sine and cosine rule? To find the unknown sides and angles of a non-right triangle. So in your trigonometry, if you remember, you must have learned trigonometric ratio for right triangle. Ratio, there are two acute angles here. If I write down here triangle ABC, where 90-degree angle is at B. So angle A and angle C, they both are going to known as acute angle. It will be less than 90 degrees. So we use here trigonometric ratio for right triangle using SOHCAHTOA here. This rule you remember. We have already seen this rule here where sine is opposite by hypotenuse, cos is adjacent by hypotenuse. So here if I am taking here sine of A or C, it is going to be opposite by hypotenuse. Similarly, if I take here cos is always here cos of A or C because they both are acute angle. It's adjacent by hypotenuse. And if I talk about tan A or C, it is always opposite by adjacent. So what do we call? So you have already learned about this. So whenever you have to just remember, whenever there is a 90-degree, opposite to 90-degree, we always call it as hypotenuse. And where do we use this trigonometric ratio? To find out the unknown angle or side? Other than that, you know that because it is a right triangle, so if I take this side as A, this side as length as B, this side length as C, which is hypotenuse. So using Pythagoras theorem, we know that a square plus b square is equals to c square. So whether you take here trigonometric ratio or Pythagoras theorem here, everything is about right triangle. But how do we find out the side length or the angle for non-right triangle? So there we use sine and cosine rule. So in this topic we'll see, we will use sine and cosine rule to find out unknown sides and angles of a non-right triangle. You will see there is a rule that you have to remember, sine and cosine rule, but how do we derive, how do we reach to that rule? We will see that along with the example, and then we are going to consider the exam based question. Now in cosine rule, you can see that there's no right triangle. If you will see here, triangle ABC is an acute angle triangle, whether it is acute angle triangle or obtuse angle triangle. If you will see, capital A opposite side length is small a, capital B is the angle here, B is the angle, and opposite side length is small b, and capital C here is the angle representing angle, and C, small c is representing the length of the side opposite to angle C, which is side AB. Now you will see that these three rules here I can remember. You can remember any one rule, then other two automatically you will get it. So here you have to remember, whenever I am taking one of the side, if I'm talking about angle A, so angle A is the included angle between AB and AC. That means here C is there, here B is there. So whenever this is the case, then we take B square, this square plus this square minus 2BC cos A, because angle A is the included angle is equals to A square. So what are we finding here? We are finding here length of the unknown side, right? So finding length of the non-right triangle. Now how do you reach to this rule? So any one rule, we will see that how do we derive this rule. So for whether you are talking about a acute triangle, so here ABC, if you will see, this is acute triangle. Here triangle ABC, it is an obtuse angle triangle. Now what you will do first, if you will see here, CD is perpendicular to, in both the cases we'll see. First let us take here this case here in triangle ABC. If you will see, CD is drawn perpendicular to AB, and we have taken CD is as H. Now CD is dividing here AB into two parts here, because the total length was AB was C. Right, so here if I consider this as x, the remaining length is going to be equals to C minus x. Now because if you see here, you see squares. Now when do you get squares in right triangle. Now, if you see CD is perpendicular, so you are getting here there are two right triangle. So in these two right triangle, you will try to apply the Pythagoras theorem. So first, if I'll take here in triangle CDB or BDC here, where it is 90° at B. If I use the Pythagoras theorem, the hypotenuse is a square. Always remember 90° opposite side is going to be hypotenuse. So a square will be equals to h square plus c minus x whole square using Pythagoras theorem, because now you have converted your non-right triangle into right triangle and you are trying to use here Pythagoras theorem. Now if you will see in both the triangle, because I need to relate the length, the relationship between ABC. So I am going to consider this triangle as well as this triangle, right? So what is going to be the other triangle in triangle CDA, where it is again 90° at D. Here, what is the hypotenuse? It is B square, which is going to be equals to h square plus x square. Now, these are the two equations. If you see first equation and second equation, what is the common side here? CD is the common side. That means in both the cases, h square is common. So what I'll try to do, I'll convert both the equations in the form of h square. So from here, if I take it, h square will be equals to a square minus c minus x whole square, and here h square will be b square minus x square. So if I label this from 1 and 2, if you follow substitution method, because they both are equals to h square, so they both are going to be equals to each other. This is first equation, this is second equation. In first and second equation, they both are equal to h square. So equate both together here. So it will become a square minus c minus x whole square equals to b square minus x square, right? Now here you have to use a minus b whole square. What is a minus b? Identity here. A square plus b square minus 2ab is equals to b square minus x square. Now simplify this bracket here. You will get everything in terms of here a square, b square, c square, and we have to do something, so that we remove x, because I need to get here equation in the form of the relationship between a square, a, b and c. So here if I transpose this whole thing, it will become here positive c square plus x square minus 2cx. Now here x square gets cancelled. A square is b square plus c square minus 2cx. Now we reach to if this is equation 3. Now if you will see in your rule, you don't see here x. This is the extra part that we have considered in the length. The whatever is given in the triangle, it is only the length ABC. There is no x. Now how can you get this value of x? I can use here trigonometric ratio to get here x. If you will see, this is angle A. I can take here adjacent by hypotenuse. Again, we will not consider h also, because h is also unknown. We need the relationship between ABC. So which trigonometric ratio I can use for angle A in the first triangle? Cos rule. So here it will be cos A is going to be adjacent by hypotenuse. So here cos A is adjacent is x, hypotenuse is B. Right? So, and here what will be the value of x? B cos A. Now from 3, if in equation 3, if you substitute x, you will get a square is equals to b square plus c square minus 2bc cos A. So how can you remember this rule? See, this rules looks difficult, but if you remember here, I'll tell you a easier way here. Instead of vertices of the triangle, you don't need to write down. You should know I'm having an angle which is known as included angle and the two length of adjacent side, which is B and C. What is the opposite side here? A. So what do you take here? I take here this, the included angle, two sides, sum of those squares. So b square plus c square minus 2bc and included angle, which is cos A. Same thing if I'm writing here what are the other two things? If I'm writing here b square, the angle b will be the included angle and a and c will be the adjacent sides here. So a square plus c square minus 2ac cos b. Whatever side is there opposite to that angle will come here. If I'm taking here c square, the remaining two sides are a and b, so a square plus b square minus 2ab. And what is going to be c's opposite angle? It is angle c. So this is the way we get this rule. Any one is fine, because what you need to remember, what is the angle? If I need to find out the length of the side opposite to the given angle, included angle, where the two sides are given. So where do we use this? When two sides and included angle is given, then you use this cosine rule. Okay, angle is given, then you use it. Now what is the second scenario? You may get an obtuse triangle also, because if you will see here, your second triangle is an obtuse triangle. Now for this also you can apply the same rule here, because here also, but here what happens, because it is an obtuse triangle, you are getting perpendicular outside the triangle. So what will happen here, if you take this AB length is C, the total length will become here C plus X. That you need to remember. Then other than this also, and you are always going to consider the right triangle, because when you consider the right triangle, then only you can take here Pythagoras theorem. So CD is perpendicular on BD with AB, right? So how do we take it here now? Perpendicular length is nothing but height, so H is also coming here. Now let us take which two triangles you will take it. So first I'll take here in triangle BDC, where 90 degree is at B, and what is going to be the hypotenuse? This is 90 degree. So side, this length A is going to be hypotenuse for the bigger triangle, and for smaller triangle B is going to be the hypotenuse. So let us take here Pythagoras theorem in triangle BDC. I can take it here, h square plus c plus x whole square is equals to a square, right? So this is again here Pythagoras theorem you are using, Pythagoras theorem. Right, now here again I need the value in terms of h square, because you are going to simplify this. See, you are going here, you are getting c minus x, here you are getting c plus x, but you will reach to the same result. So if I open the bracket, again you will use here a plus b whole square, which is a square plus b square plus 2ab, right? The identity here, a plus b whole square identity is a square plus 2ab plus b square. If I use this identity, I'll get it here, c square plus x square plus 2cx. Now open the bracket here. This is h square, which is a square, minus c square minus x square minus 2cx. Right? Now after that, what is the other triangle I have to consider here? In triangle, the other right triangle, if you will see, that is CDA. Right? In triangle CDA, where it is 90 degree at uh, angle D. Now this small triangle, the hypotenuse is B. So it will become here h square plus x square is equals to b square. And what do I need here? I am having here x square value, b square minus x square. Now when you do this, this is your third, fourth equation, this is your fifth equation. Now they both are equals to h square, so they both will be equal to each other. So here if I do the continuation here, how will you do it here? A square minus c square minus x square minus 2cx is equals to b square minus x square. Now I need the value of a square, so a square will be equals to b square minus x square plus c square plus x square plus 2cx. And again x square and x square gets cancelled, but still you will have one x left here. Now this x you will remove it using trigonometric ratio. Now look at here, which triangle we are taking here. I need to get the relationship between trigonometric ratios such that x can be removed. So if I'm talking about this angle, which is 180 minus a, so in triangle CDA, if I take it here in triangle CDA, I am going to consider again angle A, which is 180 minus A, and again adjacent by hypotenuse. So how do we get it here? It will be cos 180 minus A, which is equals to x by b. So what is, now you have to know that here whenever there is a cos 180 minus theta, that will be always minus cos theta. Okay, so that is going to be, this is the rule you have to remember. Complementary angles, supplementary angles rule will be there. So then in this place I can write down here minus cos A, because angle A is theta. So it will become here minus cos A times B, here minus B cos A will be equals to x. Now you need to just substitute in this equation, so it will become A square is equals to B square plus C square plus 2C times minus B cos A. Now you are reaching to the same result whether you take acute triangle or obtuse triangle, your cosine rule is same. So cosine rule, where do we use here? We are using when the two sides and one included angle is known. You can see that here always you have to remember two sides length and the included angle is known, then you can find out the length of the opposite side. Now, other than that, you should know here, we can find out here, this one is 2BC here, it will be cos C, right? Now, you are having three rules. So, just now we have discussed if two sides are known and the included angles are known, we can use cosine rule to find out the third unknown side. But here, if you see, there are angles also. So, if angles A, B or C are missing, and if they have given, if three sides are given, sides length are given, then also you can use cosine rule. So given, then we use cosine rule here, cosine rule to find the unknown angle, to find unknown angle. Now whenever unknown angle is there, it's based on whichever angle is unknown, you can use this rule, because you just need to do the transposition here. So again, if I'm having a triangle here, if I'm having a triangle where ABC are the three sides here, ABC are the three vertices, and opposite to vertex A the length is small a, opposite to vertex B length is small b, opposite to angle C the length is small c. Now here what are the three rules you have learned? If I'm talking about A square is unknown. Now A is unknown, the opposite angle is here, this is angle A. Write down here B square plus C square minus 2BC here cos A. This is to find out the length of side BC. But if I need to find out angle, then I can transpose here. How? It will become 2BC cos A. So you don't even need to remember this rule. Using the basic rule, the cosine rule, you can derive angle A. So it will be cos A, which is B square plus C square minus A square by 2BC. Now again, how are you going to use? If I need to find out the included side and all the three side lengths are given, whichever angle is known, the opposite side you have to see it. The opposite side you are going to subtract mine by 2BC. Now how to get here A? A will be here cos inverse B square plus C square minus A by 2BC. Similarly here, if I have to find out angle B. This angle A, angle B. Now opposite to angle B, what is the side here? B, and the sides are A and C. So you can take here A square plus C square minus B square. So whatever angle is there, opposite side square must be subtracted by 2AC, and this whole cos inverse you have to take it. Similarly, angle C, if I'm talking about, if you transpose, you'll get the same thing. Angle C, if I do it, it will be cos inverse. Now, opposite to angle C, it's a small c. So, the included c is included between a and b. So, a square plus b square minus c square by 2ab. So this is the formula cosine rule to find out any unknown. Sine rule also, if you will see, we used to find out the length of unknown side or angle for the non-right triangle. Now here, where do we use it here? If two angles and one side is known, or two sides and the non-included angles are known. See, in some cases you will see you can use sine or cosine rule both, right? So how do we get this? If you will see, this is the rule. If you see sine A by A, so if angle A is there, the opposite side, you instead of ABC, you have to remember an angle and its opposite side. So sine A by its opposite side, sine B by its opposite side, which is B, and sine C by its opposite side, C. Or you can take the reciprocal of all. If I'm taking the length A, its opposite angle is angle A. So A by sine A, B by sine B, C by sine C. Why this rule is true here? Because if you will see the derivation of this rule, you know whenever we are having non-right triangle, we will use here area formula to find out the sine rule. What is the area formula? You know it is half AB sine theta. So for angle A, if I take it, if I consider angle A, you know that because area, whatever included side and angle, I take it here. Any angle between two side, any included angle, the area will remain same. So first start writing here. Can I write down half? Now, if I am considering sine A, the two sides are going to be B and C because A is included between length BC. So, BC sine A will be equals to half. If you see that if I'm talking about angle B, the two sides are AC. So, area will be half AC sine B. The same here if I take angle C, the two sides will be because C is included between length A and B. So sine C. So all three of them are going to be equal because they are representing area of the same triangle ABC. Now from all three equation, I can take half common and divide each one by ABC because here I need to get it into this form. So if I divide all the equation by ABC, whatever operation you do it to one side of the equation, you have to do it to all the sides. So you can see when you do this, BC gets cancelled here, AC gets cancelled here, AB gets cancelled. So you are left with sine A by A, which is equals to here sine B by B, which is equals to here sine C by C. Or if I take reciprocal, if length is unknown, if angle is unknown, generally we use this. If side is unknown, I can take the reciprocal. Or you can use any this one formula here. At a time, you can equate any two values, right, out of these three equal values. So this is called sine rule. Now other than that, you have to remember before we start solving question, cosine rule we use when the three side lengths are known and two sides and an included angle. That means the angle between those two sides are known. Sine rule we use it when one side and two angles are known or two sides and the non-included angle are known. But beware of an ambiguous case which can occur when the smaller of two given side is opposite to the given angle. So you will see some questions where there are ambiguity. You can use sine or cosine rule both. So based on the given information, you can do it. Now your first question, it says here, find 2 till 2 correct decimals, the length of BC. So first you observe the triangle. Now this is the triangle. If I take it, this is given as A, B and C. Now here 42 degrees are known and 11 centimeter and 13 centimeter is known. Now whenever what we need to find out here, put a question mark. Now if you observe this, A is the included angle between AB and AC and the opposite side is unknown. So what do you observe here? Two sides and included angle and one included angle. If it is the case, see, starting you may take some time, but once you solve enough number of questions, it's very easy to identify whether you have to apply sine or cosine rule. So here you are going to use cosine rule. Now cosine rule, you don't even need to remember the rule. What you need to see, the unknown side. So unknown side square equals. So if you want, you can write down the formula also, because here it will be, formula will be a square will be equals to b square plus c square minus 2bc here cos a. How to do it without remembering this also you can do it. The opposite side is known. So you will write down first that square. It's here ab square plus ac square minus 2ab times ac times here cos a, because opposite angle is cos a. Or directly I can write down here 11 square plus 13 square minus 2 times 11 times 13 cos 42 degree. Now other than that, you have to take here square root of this. So it's coming here, if you take it approximately, you don't need to write down, but if I write down here 4605, right? And if you take the square root of this value, you are getting here till two decimal places, means it's coming 8.801, which is going to be 8.80 centimeter. Let us go for the next question here. There is no figure given. Whenever there is no figure given, you will always first draw the rough figure so that you understand the question in a better way. So it's given in a triangle ABC. What do I need to find out here? Measure of angle C, because here the vertex, it's given here, it is always taken the middle vertex here. So draw a rough figure for the triangle here. Now, if I mention here A, B, and C, this angle is unknown, we need to find out, right? Now, mark here AB length is given as 7 centimeter, BC length is given as 5 centimeter, CA length is given as 8 centimeter. Now, whatever angle is unknown, because A part you need to find out angle C. What will be the formula here? You can start with the normal formula and later you can transpose, because the first formula a square is equals to b square plus c square minus 2a bc cos a. It's easy to remember. So I'll start with here 7 square, which is 8 square plus 5 square minus 2 times 8 times 5 times here cos c, and you can make here cos c as a subject. Or if you remember the rule, I can directly take here cos c, then you take here 8 square plus 5 square, then opposite side square needs to be subtracted by 2 times 8 times 5, right? So again here cos c will be 64 plus 25 minus 49. You can use here calculator. 40, it is going to be here 80. Cos inverse half. Now if you remember, half is how much cos. Without calculator also you can solve it, because you must know it is cos 60 degree. Cos 60 is half, which is sine 30 also. So C is going to be equals to 60 degree. So which is nothing but angle BCA 60 degrees. So whether you use calculator or without calculator, you got it as 60 degree. Now there is a second part also. Find the exact area of triangle ABC. So half AB sine theta, angle C is known, you got it as 60 degree, and you will take the two side next to that angle. So here B part, if I am solving here, you will write down area of triangle ABC will be half times AC. I'm writing this, you can directly substitute the values also. It is sine C. Now if I can directly write down here half times 8 times 5 times sine 60. Now sine 60 is root 3 by 2. So here if I take it, 4 20 times here, if I take 20 times root 3 by 2, sometimes the answer can be written in insert form also, 10 root 3 square centimeter. Let us go for the next question. Now in this question, if you see here, already the triangle is given. We need to find out the length of side AC. So first you put the question mark. If I redraw this triangle, So what is the unknown here? This is ABC. A, B, C are the three vertices, three angle. This is given here 58 degree, 39 degree. You can always find out the unknown angle also using angle sum property. Now what do I need to find out here? Length of AC, put a question mark. So whenever you see this, three sides are not known and one angle and the two included sides are not given. See here for cosine rule, we should have this side length also to find out this. We can't use. Or to find out the angle, all the angles are known because here I can using angle sum property. What will be angle A will be 180 minus 58 plus 39, right? But that is also not needed because I need to find out opposite side here. Now it was written here, what was the second? I will be using here sine rule. If you remember here, see what is written here, two sides and non-included angle. That's not the case here. One side and two angles are given. If you see this, this is one of the side length which is 12 centimeter is given and two angles are given. So you see the angle and its opposite side. 39-degree opposite side is 12, right? So I can write down what is the rule, sine A by A, which is not even here, sine B by B, which is equals to here sine C by C. Now in this case, what are you going to use? At a time you can equate any two values. So I'll take here sine B. What is sine B here? Sine 58 by opposite side, which is AC, that is unknown, is equals to sine 39 by 12. So here if you will see, AC is unknown, make AC as a subject. So AC will be 12 times sine 58 by sine 39. We'll be getting here till two decimal places, it's coming 16.1707. So for till two decimal places, it will be 16.17 centimeter. So this is the way we use sine and cosine rule. Now this question, if you will see, it is from 3D trigonometry or you can take it from surface area volume. But in this case, we are just finding the angle. What is given here? Find out the measure of angle RPV. Now here RPV, if you will see, this is the 3D figure, right? So what is the triangle we have to consider here? This is the triangle we have to consider. So if I redraw this triangle here, now this is in 3D. So each faces, each of this side length you need to first find out. So this is P, V and here it is R, right? PVR. This angle is unknown. Now for this unknown angle, I must have all the three sides because this is the angle is unknown. No side length is known, no angle is known. So what I'll do here, but you can see that here, if you are taking PV length, I can consider the front face to calculate RV length. I can take here this using Pythagoras. To find out the PR, I am going to consider this length and this length. So let us start it here one by one. We'll take it here. First PV length is the hypotenuse for opposite to U angle, which is 90 degree, PUV, right? So, and we can take it here root. What is this opposite side? Height is 3. So it can be taken as 3 square plus 6 square, which is 9 plus 36, and 9 plus 36, if I take it here, it is going to be here root 45, right? So I'm just writing here root 5 centimeter. Similarly here, if I'm taking here RV length, so this length we got it as root 45 centimeter. RV is the face hypotenuse opposite to 90 degree, R angle RWV. So we can take it here 3 square plus 5 square, which is 9 plus 25, which is going to be root 34 centimeter. So this length we got it as root 34 centimeter. Similarly here, if I take PR length, that is opposite to angle S, which is 90 degree, which can be taken as here. Now none of the here sides are known, but opposite sides are equal. So this will be 6 centimeter and this is the width, so that will be 5 centimeter. So I can take it here as 5 square plus 6 square, which is going to be 25 plus 36 will be here root 61 centimeter. So this is root 61 centimeter. Now I need to get angle P, right? So till now we have used Pythagoras theorem because we are able to see the right triangle. Now how to know here three sides and angle is unknown. When the three sides are known, you know that we can use here cosine rule. What is the cosine rule? Here we can write down here cos p will be equals to here. What are the two? P is included between which two sides? PV square plus PR square. So you can write down here root 61 square plus root 45 whole square minus square of opposite side, which is root 34 whole square minus 2AB. So this is the P is included between PV and PR. So 2 times root 61 times root 45, and once you simplify this, and if I take the cos inverse here, P will be cos inverse 61 plus 45 minus 34, because root square, the root will be removed, right? So this can be here 2 root 61 into 45. If I take it here, we are getting here 2745. Now you are getting here 46.59, but angle cannot be written till two decimal places, so you know that it will become here 46.6 degree approximately. Answer angle will always be written till one decimal place. Again, bearing based question, sine cosine rule is very common. So let us see here. There is one question. A yacht race follows the triangular course, and already the figure is given shown in the diagram. The course P to Q, that means from P to Q, 1.8 kilometer on a true bearing of 58 degree. So P is the start point here. So Q from P is going to be 58 degree. You first need to mark it. Then at Q, the course of direction changes, right? You can see that here, the course from Q to R, here it is 2.7 kilometer, right? Then and angle PQR is given 74 degree. First thing, how will you calculate what is the bearing of R from Q? You need to take it here, R from Q, or Q to R also it can be there here. Q to R means the line segment is QR, so in the clockwise direction till here this angle. Now what is the unknown here? If I divide it into parts, if I take this is already 180 degree because it's a straight line. Now if you will see, alternate interior angles are always equal because north to north always parallel, and you will always go known to unknown angles. So this angle will be also 58 degree. So what is going to be your bearing here? R from Q, it is going to be 180 plus 58 degree plus 74 degree. If I do this, what is the answer? 180 plus 58 plus 74. If I take it, it is coming as 312 degrees. So bearing of R from Q or Q to R, this angle is going to be here 312 degrees. If I need to find out here R to P, this total distance from R to P, this is unknown. Now if you see that, you need to see the triangle because RP is the part of this triangle. Right now 74 degree is known and two of the sides are known. So two sides and one included angle is known. So second part we can use here cosine rule. We can take it here in triangle RQP, right? Angle, this one is there. So what can we take it here? Because RP is unknown, using cosine rule I can take here RP of PR square will be equals to 2.7 square plus 1.8 square minus 2 times 2.7 times 1.8 times cos 74. And if you do simplification here, the square will go to the other side and you need to calculate this value. So PR length, it's coming it as here 7.8508 approximately, and if you take the square root of this value, it's coming it at 2.8019, which is here 2.8 kilometer. Then what is the third part here? The area inside the triangular course, because now they are talking about this triangular course. What is given here? The area is set as a no-go zone, right? for other boards while the race is on. What is the area of no go zone? So you can write on here area of triangle RQP will be equals to half AB sine theta. Now theta, it should be the known angle which is 74. So the two sides A and B will become 2.7 and 1.8. So I can take it here half AB sine theta 2.7 times 1.8 times here sine 74. 2.3358 kilometer square, because it's an area, so it will be 2.34 kilometer square using three significant figure, right? After that, here this question is also very important, the fourth part. What is the shortest distance of R from PQ? Now remember one thing, whenever you are talking about the shortest distance is always taken as perpendicular. So if I draw the perpendicular from R to PQ, this is called, H is called here shortest distance. If I write on here RS, which is H, is always, because shortest distance, if I'm taking a triangle, right? So if I take here PQR, what is the distance of A from PQ? They can be infinite, but what is going to be the shortest distance? It is always going to be perpendicular. So shortest distance is always perpendicular distance. Now because I'm having here right triangle and 74 degrees is known, I can use any trigonometric ratio. So H is opposite to 74 and hypotenuse is here 2.7 here. So opposite by hypotenuse, I can use here sine rule. So the fourth part, if I'm taking here, I can take sine 74 will be h by 2.7. So what is the shortest distance? It is 2.7 times sine 74, which is coming it as 2.595 here kilometer, 5 kilometer, and if you take it here 2.6 kilometer approximately, it is the shortest distance. Now this is your past paper based questions here. What is there in the first question? It says in the diagram below, the angle ABC it's given as 30 degree, angle BAC it's given as 45 degree here, so 35 degree, 45 degree. BC length is given here. This we need to find out, we need to prove that AC length here it is 5 root 2. So already given, that means the follow-up question you are going to use AC length. So they don't want you to go wrong. That's why you need to show that. Now to show that, if I take it here, 30 degree is known and opposite side is unknown. Similarly, 45 degree opposite side is known. Whenever this is the case, this is, you are going to use here sine rule. Sine A by A, which is equals to sine B by B. So if I label this as B, it is AC length, right? Equals to sine C by C. You can equate any two. So what is there here? Sine 45 by 10, which is sine B is sine 30 by AC length, right? Now here if I do the, make AC as a subject, it will become 10 times sine 30 by sine 45. Now sine 30 here, sine 30 value is always 1 by 2, by sine 45 is 1 by root 2. So 2 ones are 2, 2 fives are, so we are getting here 5 times root 2. You will take the reciprocal of the denominator, root 2 by 1, which is 5 root 2 centimeter. Second part of the question. Now it says if side BC is extended by 5 centimeter, which is demonstrated by the animation below. So here it is not given, but in your E assessment you will see BC is extended means till D here, right? And find out the length of AD. So here till, if I am taking it here, this is, and you have to join A to D because you need to find out the length of AD, that is unknown. How much it is extended? By 5 centimeter. Now you can go known to unknown. I need to find out this. So let us see here how will you do it. So first you find out the unknown value, which is angle ACB. What is going to be angle ACB? You can use angle sum property of a triangle, which is 30 plus 45 degrees, which is 180, minus 75 degrees, which is 105 degrees. So this angle is 105 degree. So the adjacent angle is going to become here, this angle is going to become 75 degree. Now here, if I need to find out this one, you already got AC length also 5 root 2 centimeter. So if I consider this triangle, you can see that two sides are known and the included angle is 75 degree. Opposite side is unknown. You will use here cosine rule. So if you are using in triangle ACD. If you are using this triangle, you will use cosine rule. What do I need to find out? AD square will be equals to 5 square plus 5 root 2 whole square minus 2 times 5 root 2 cos 75 degree. AD square will be 25 plus 50 minus 50 root 2 cos 75 and square root of that value. After that, AD is root 56.698 approximately. That is equal to, if you take the square root, it's coming 7.5298 centimeter, and 3 significant figure, if I take it, it will be 7.53 centimeter. This is the answer. Okay, so AD to the nearest centimeter they are saying. So what will be the nearest centimeter here? You have to read the question. Sometimes if nothing is given, you will write down as 3 significant figure, but here it's written nearest centimeter. It's going to be, answer is going to be here 8 centimeter. That is going to be your answer. Is there any other way can we find out here AD length? Now, because here, if I find out this length, now look at here, but for that we need to do one extra step. If I take the big triangle, if I can find out this length using sine rule here, because 105 is known, then I can use cosine rule for this big triangle also. It will be AB square plus BD square, and you can take here cos as 30 and opposite side will be AD. So anything you do it in both the cases, if you are taking this here, first you have to use sine rule and then you can use cosine rule. Let us go for the next question. Now here, next question you will see here, it's given as a 10 marker, right? What is the first part? So sine cosine rule, always it will be 3 to 5 marker question, then it will be integrated with some other topic. So what is given here in the first part, if you will see, it's given the diagram shows triangle ABC. We need to find out the angle ABC. That means angle B, you have to get it. Now you know that all the three sides are known. That means we have to use here cosine rule. In cosine rule, when the angle is known, I can take it here cos B will be equals to the L square plus 20 square minus opposite side square by 2 times 12 times 20. So B will be equals to here cos inverse. If I do this simplification, I am getting here minus 0.5. And if you take cos inverse of that answer, you are getting here 120 degree. So this angle, you are getting it as 120 degree. So here angle ABC here is equals to 120 degrees. In the next question, if you want, you will see it's given AB and BC are extended. You can see that here AC and BC are extended here. So you can see AC is extended and BC is extended. Then to form the triangle DEC, this triangle is formed, right? Such that AB is parallel to ED. So AB is parallel to ED and triangle ABC and DEC are similar. Now movement here you will see after trigonometry it has been integrated with similarity of triangles also. So first you write down whatever is given. Triangle ABC is similar to triangle DEC. Now the movement triangles are similar. You know that their corresponding sides will be in equal ratio and their corresponding angles are also equal. So AC by DC. Now what do I need to find out in this part here? You need to calculate EC. What is EC here? If you see, EC is the part of this. So what is the length of AB here? Substitute here because we are going here corresponding sides of corresponding sides ratio of similar triangles are equal. Ratio of, you need to write down everywhere wherever required reasoning so that you don't lose marks in communication part. Corresponding side ratio of similar triangles are equal or they are in proportion, right? So substitute AB is 20 by DE is given as 15, which is equal. So you will equate these two because I just need to find out EC. BC is given as 12 by EC you need to find out. If you need to find out DC, then you can take this 28 by DC also. So here make EC as a subject here. So EC will be equals to 12 times 15 by 20, 5 threes are, 4s are, 4 ones are, 3 1. So you'll be writing here 9 units only. What is the next part? If you'll see the weightage is here 5 marks. What do I need to find out here? The value of L, that is the horizontal length. Now in this part, if you will see horizontal length, now there are two triangles. So how can I do it here? Because using this, I have to using these two triangles, I have to find out the total distance horizontal length between A and D. Now here if I extend this, if you see this, because this is parallel to horizontal length, I have to use the dimensions of the known value, whatever the triangles values are given to find out the unknown. Now if you see this part, you can see here this length is known, and from here also if I take this length, because the opposite sides are equal. So this part is here 15 units, this part is here 20 units, and I need to find out the unknown length, which is x. If I take this now, because this is 90° and this is parallel to this is also 90°. Now we already got EC length as 9 units. So you can see that here this triangle is a right triangle, right? If I know one of the angle, I can use trigonometric ratio to find out the unknown value. Now this angle you already got it as 120 degrees, so this adjacent angle will be 60°. Now see here there is a similarity, there is a trigonometry, and in that you are using sine cosine rule also. So which triangle I have to consider here? In triangle, if I name this as P here, right? In triangle BPE, where here it's given this, what is the length here? BE length is, BE length total will be 12 plus 9, which is going to be 21 units. Then angle EBP, it is 180 minus 120, which is 60°, using linear pair angle on a straight line, sum up to 180°. Now which trigonometric ratio you'll use to find out x? We'll use here, because hypotenuse is known and adjacent is unknown, so you'll use here cos 60 will be equals to x by 12 plus 9, which is 21. So x is going to be 21 times cos 60, and cos 60 is sine 30, which is half. 21 times half, which is going to be 10.5 units. So what is going to be the horizontal length? The sum of these three parts here. So L will be 20 plus 10.5 plus 15, which is going to be 45.5 units is the horizontal length. So this is the way you solve. You use sine cosine rule to solve the questions. Hope you got this.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.